Welcome to the module on basics of estimation. In this module, we will be covering the number of cubes or beams required in a rigid pavement for meeting the samples to be casted in the project, depending upon the quantity of concrete which is being paved and the length of the rigid pavement which is planned to execute. Some of the guidelines to use in the Excel sheet is the sheet which is being developed is completely logged. Only the cells which are blue in color will take the input value. Those in terms of the quantities, the dimensions, the length, width, and the thickness of the paving, and the planned quantity. The number of cubes required for DLC or PQC and structural steel, structural concrete will be calculated in separate sheets so that this sheet can be used for both rigid pavement as far as for the other structural concretes where you have no rigid pavement scope. There you can directly calculate the quantities required for structural work. So this is basically a unique sheet developed which can be used for rigid pavement in specific, and also to calculate the number of cubes required in the project, to calculate the size of the curing tank required in the project, whether you have the PQC or you don't have the PQC. The DLC cubes were assumed to be tested for 7 days only. There is no consideration for 28 days compressive strength is considered while calculating the size of the tank or the number of cubes required for DLC. The number of tanks can be planned in the project, which will be an input value varying from 0 to 10. The width of the tank can also be assumed depending upon the land availability, so that the third dimension can be calculated depending upon the area required for curing. The surface area for DLC calculated using the width and length of DLC paving in a day. For DLC, one sample is cast for every 1000 square meters of paving to be tested at 7 days. For PQC, one sample each is cast for every 150 cubic meters of concrete paved to be tested for 7 days and 28 days. So if you see the frequency which is being considered for calculation of cube casting in structural concrete, it is in line with IS 456. That is, for quantities from 0 to 5, one sample is considered. For 6 to 15, two samples, 16 to 30, three samples, and 31 to 54 samples, and thereafter for each 50 cubic meters, one additional sample will be added to the required quantities. And when we say the 1, 2, or 3, and 4 samples, these are the samples which are required to be tested for 28 days compressive strength. In case you require additional cubes to be tested for 1 day, 3 day, or 7 days, or 14 days, you need to incorporate those values in the calculation sheet. But by default, we have considered one sample to be tested for 7 days, and rest based on the IS 456 requirement, which is being used in the calculation for determining the number of cubes required and the size of the curing tank. Frequencies of beams and cubes required in PQC, that is pavement quality concrete, will be for each 150 cubic meters, one set of beams and cubes is required. And so 151 to 300, two sets required. 301 to 450, you require 3 sets. 451 to 600, you require 5 sets. 601 to 750, you require 5 sets. Similarly, you go on adding for each 150 cubic meters one additional set of beams and cubes to be casted for testing. Similarly, for each 1000 square meters, you require one set of cubes to be casted for DLC. Now, for every 1000 square meters, you have to add one additional set of cubes to be casted for DLC. And when we say one sample, it is basically a combination of 3 number of cubes, which forms one sample or one set of cubes. And the cubes of DLC are to be tested at 7 days in order to ensure that it achieves 10 MPa strength. Then By using your executive summary sheet, you will be able to estimate the size of the curing tank. Now, the beauty of this executive summary sheet is you need to input the data on the cells which are being marked in blue. Like if you say you have a DLC in the project, then probably you need to enter the length which you are planning to pave in a day, the maximum length which can be planned, or the average length which can be planned to pave in the project. Then do you require samples for 1 day test or 3 day test? That also you need to enter, and then the quantity of PQC in terms of cubic meters of concrete, the quantity of structural concrete in terms of cubic meters per day in the concrete. Then you will also get you will also need to give the details of the clearances required all around the cubes and beams while storing this in the curing tank, because the clearance will add the additional space for curing tanks. So depending upon that, you can also legitimately put what value you want to add, whether it is 20 millimeters or 50 millimeters all around the clearance for keeping the cubes in the curing tank. Then you need to put the thickness of the DLC, the number of tanks which you want to plan, the one dimension of the plant tank, which can be either width or length. In this particular case, we have taken width as the input dimension. Depending upon the area and the land availability, then automatically you will get what is the number of tanks required and what is the length and width of the each tank required to make in the project, and then what is the number of cube moles required in totality in the project. In this particular sheet, we have shown only the structural concrete, which is amounting to 500 cubic meters, and we will be requiring around 135 cubes in total. Figure shows the typical arrangement of a curing tank in the project site, where you normally have two tanks. One is dedicated for keeping the cubes of 28 days testing, and the other one is kept for testing the cubes at 7 days. So this is how the area looks like. The total area is being divided into two parts, where you keep at one location at any point of time. You can see that the 7 rows on the first tank, which is being tested on 7 days, will be always filled with cubes, because for each consecutive day, the one which is behind, that is in the column 1, will get cleared off by the time you fill up the 8th column. Similarly, the cubes are being placed at designated places in 28 days curing tank. That means this tank is used for the cubes storage, which needs to be tested on 28 days testing. So this will help you in the project to trace the cubes very easily with respect to date and with respect to the location where it is being placed. Now each box indicates one sample of the cube, like one sample means three number of cubes. So this is how the cubes are being stored. This is how the cubes are being traced out in the project easily on a daily basis. But in order to understand that how big the tank should be, what should be the number of tanks, how do you store so that each and every cube at the time of testing can be easily taken out, what is the maximum number of cubes which can be tested in a day, or what is the possibility that in a project what will be the maximum number of cubes which you will get for testing. So these are the things which one has to calculate at each project in order to make sure that there should not be any surprises when they actually start testing. Meaning is based on the number of cubes to be tested, based on the number of beams to be tested in a project, the area required to store the cubes, the area required to store the beams for curing, as well as for testing and as for disposal of the broken cubes and beams, needs to be planned accordingly. Now, this Excel sheet will help you to calculate how the number of cubes to be tested can be calculated, how the number of cubes to be casted in a day will be calculated using simple techniques in the project. Like when you see for structural concrete, this is the sheet, the calculation sheet which is being dedicated for calculating the number of cubes required in order to test or in order to cast in a day, depending upon the quantity of concrete, depending upon the quantity of concrete which is being planned per day. Like for example, if you see this column A4 or cell A4, that is column A, row number 4, you see the number 500. So this is the quantity in terms of cubic meters which is being planned in a day. Now, you all know that as per IS 456, you have a set of frequencies for sampling of cubes, and those cubes needs to be tested on the 28 days strength. Now, if you require more cubes, like 1 day, 3 day, or 7 days, then the number of cubes needs to be casted will depend upon the requirement. So that requirement you can put on top. Like if you need a 1 day cube, say you need one sample or two sample, you have to put that value there. If you need 3 days cube, the number of samples required needs to be put, but anyway we require one sample of the day's production to be tested for 7 days. So default value I have put as 1 for 7 days testing. Now when you say 500 for each shift of say 10 hours or 12 hours based on the project duration you execute, you can put the value of what is the shift value. Like in this case I have taken the first shift value as 250, so automatically the second shift value will be the total minus the first shift value, which will be again 250. So based on this 250 cubic meters of concrete which is being placed during the shift, the number of samples to be casted for testing on 7th day is one sample, and the number of cubes to be casted for 28 days will be 8 samples. So the total number of samples required to cast in a shift is 9, and so the total number of cubes required to cast in a shift will be 9 into 3, because one sample is equivalent to 3 cubes. So keeping that in mind, you are casting 27 cubes per shift, and if it is 500 cubic meters per day, then you are ending up by calculating 54 cubes, that is 27 cubes in each shift, which is a total of 54 cubes to be casted in a day. Now, when you say that you need 54 cubes to be casted in a day, then every day you need to cast 54 cubes. That means the cubes which are being casted today will not be in use for the next day, because next day those cubes will be shifted from the project site and will be placed, will be reaching the lab to demold the cubes, take the cubes out of the mold and place it in the curing tank, and then again rearrange the 54 cube molds with greasing, cleaning, all that activity. So the total number of cubes which is required in the project, if your average daily consumption of concrete is 500, then the total number of cubes which is required will be 135, which is nothing but 54 multiplied by 2.5 times. Why 2.5 times? Because anyway the 54 into 2, because next day it will not be used, and probably you will be able to use it half day on the third day. So 2.5 times the number of cubes casted in a day will give you approximately the number of cube moles required in the project. Now, keeping the size of the cube as 150 by 150, and a clearance of 50 mm or 20 mm, depending upon the requirement or depending upon the space you can plan. So this is basically occupying a space of 150 plus the clearance on all sides. In this particular case, we have taken 50 mm clearance on all sides. That means a cube will be requiring 150 plus 50 all around. So that is 200 by 200 size is required by the cubes, or generally we take 20 because all around 20 will 50 divided by 20. So 50 divided by 2 will be 25. So this is how you can find out the length of the curing tank required in terms of meters for cubes to be tested on 1, 3, and 7 days. Then length to be required for cubes to be cured for 28 days will be calculated in terms of number, that is total number of cubes divided by the dimension of the cube, okay, and multiplied by the dimension of the cube, that is the length dimension, divided by 1000 to give you the required meters. And then similarly the width will be calculated for cubes to be cured for 1, 3, and 7 days, and the cubes to be cured for 28 days. So this will give you a brief idea of what is the length and width required for the cubes to be cured for 1, 3, and 7 days. So the area will be length into width, that is 9 square meters will be the area required to store the 1, 3, and 7 days cubes for testing on their respective days. And 90 multiplied by 90 will be the area required by the cubes to be stored for 28 days strength. That means 28 days storage period will be having 90 meters of length and 90 meters of width. So the total area required for cubes to store for curing and thereafter testing will be somewhere around 8036 square meters in this condition. Now, the total area required to store the cubes which are to be tested on 1, 3, 7, and 28 days will be 8050 square meters. Now, if the number of curing tanks you plan to or you intend to keep is 3, that means the total area divided by 3 will give you the number of the area required for each tank. And then you also have the liberty to choose one dimension of the tank depending upon the land availability. So it can be 10 meters, it can be 20 meters, it can be 30 meters. In this example, we have taken 30 meters. So the 8036 square meters area is divided into 3 number of tanks with a dimension of 30 on one dimension, then the length will be 89 meters. So if you see the size of the curing tank, it will be 89 meters by 30 meters of 3 numbers of sizes. Now coming to the height, which is the third dimension, how to decide the height of the curing tank. You know that in each sample is being occupying one box. That means one box is having 3 number of cubes. So height wise you are having 3 layers of cubes, and if you keep a bottom clearance of 150, that means 250, that means 3 layers of cubes is 3 into 150, that is 450. 450 plus 250 is 700. So the total height required, the total height of wall required will be around 0.7 meters. So the vertical dimensions can be minimum required is 0.7 meters, or it can be 1 meter also, but it's better to keep close to 0.7 because it will be easy to handle the cubes which are at the bottom without entering into your curing tank, because you know that the curing tank is full of water, and if you can able to pick your cubes from outside, as the health issues will be minimized and you will be able to handle easily how the cubes needs to be taken out and placed for curing. And then the volume of the water required is also important. More the height, more will be the volume, and this water needs to be circulated every fortnightly or every weekly depending upon the external particles, because depending upon the pollutants which will pollute the water. If the tank is covered properly, then probably once in a week will be a good time to change the water of the curing tank. But if it is open, it is very difficult to maintain, but it's always suggested or recommended that your curing tank should be closed, because the idea is if it is closed, it will not have much effect of the ambient temperatures directly, but if it is open to sky, then during the summer the temperature will be very high because of the ambient temperature which goes around 45 also in some parts of the country. And in winter it goes close to zero also in some parts of the country. So it's always better to have your curing tank under the closed conditions so that the water temperature can be maintained, because as far as curing is concerned, water needs to be maintained at 27 plus minus 2 degrees centigrade at all times during the process of curing, irrespective of the fact whether your ambient temperature is 0 degrees or plus 45 degrees. Similarly, when it comes to the rigid pavement, again the number of samples required to be cast for rigid pavements will be one sample for each 3 days and 7 days. Now, what has happened is in this particular sheet, again for 150 cubic meters, you need one sample to cast. So you have cubes as well as beams. The size of the cube is 150 by 150, whereas the size of the beam will be around 700 by 150. So the number of cubes required and the number of beams to be casted can be calculated similarly. Now, the number of cubes required in case of DLC is also calculated using the details like for each 1,000 square meters you need one sample to be tested for 7 days. Now, in order to make sure that these things needs to be done, what is being done is the moment you change the moment you change the requirement, or the moment you put the requirements in the summary sheet, the executive summary sheet, which is the first sheet of this whole model, you need to put the dimensions, say like if you have the length of paving say around 500 meters, and the width of paving is 9 meters in case of DLC. That means the area paved is 4,500 square meters. And for each 1,000 square meters, you need one sample. So 4,500 means you need to cast 5 samples. That is what exactly being shown here. So if this is the area which can be, or if this is the length which can be placed in the project as far as DLC is concerned, then probably for DLC you will be requiring 38 cubes at any point of time. And similarly, if you talk about PQC, that means around say 3,000 cubic meters of PQC we plan to do in a day, then going to the sheet of the PQC, you can see that for doing a PQC of 3,000 cubic meters, what is required is you need 20 beams and cubes for 7 days and 17 cubes and 20 beams for 28 days. So this is how the total number of flexural moles required will be 300, and the total number of cube moles required specifically for PQC alone will be 278, and the area required will be around 10,000 square meters just to keep curing of these 300 cubes and 278 cubes for 28 days and 7 days testing. So again, the criteria for selecting the size of the curing tank will be, you need to have two predictions. One is what is the number of curing tanks you intend to keep in the project or you plan to keep in the project, and what will be the one dimension of the tank based on the availability of the land you decide to go for. So keeping these two parameters constant, you will be in a position to calculate the third dimension, and thereby you get the total dimension of the curing tank, whether it is PQC or DLC. But you need not go to the individual sheets at any point of time when you really want to check what is the size of the curing tank in the project is required in totality, because looking at the executive summary only, you will be able to check what is required. Why? Because for area of curing tanks, if you see, we require 9 square meters for DLC, 10,000 square meters for PQC, and 8,000 square meters for structural concrete, and the total area required is around 18,168 square meters. Now, this 18,168 square meters, you are planning to take three curing tanks. So if you intend to take four curing tanks, then the single dimension will be 30, then probably the length will be reduced to 151 meters, and if it is 3, your length will be around 200 meters. So depending upon the land availability, you can choose a number of tanks. It can be any number of tanks, but should be feasible to construct in the field. And similarly, the number of cubes and the number of beams required individually, if you see the number of beams, of course the beams are required only for PQC, so in other areas it is blank. But for PQC, when you intend to do 3000 cubic meters of concrete in a day for PQC, you will be requiring 300 flexural beams in the project. And for other parameters like DLC, PQC, and structural concrete, the number of cubes required individually will be 38, 278, and 135. So in totality, you will be requiring around 451 cube moles in the project. If you want to do 500 meters of DLC daily, if you want to do 3000 cubic meters of PQC daily, and if you want to do 500 cubic meters of structural concrete daily. Now, if you say you require only 300 cubic meters of structural concrete daily and you require 2000 cubic meters of PQC, and probably you will be doing only 300 meters of DLC, then your requirement for cubes will drop from 451 to 338 number of cubes, and the number of beams will be reduced from 300, it will become 210. So this is how you can plan what is the number of beams or the number of cubes required in the project, whether you have DLC or you don't have DLC, whether you have PQC or you don't have PQC. So in case in a project which is a flexible payment and you don't have a rigid payment, so your quantity related to DLC will become zero and the quantity related to PQC also will be zero. And probably you plan to do 500 cubic meters of concrete, the structural concrete in a day, then you possibly end in making or requiring 135 cubes in the project. And in that condition, what you can do is you can reduce your number of curing tanks to 3 if you have land, and then probably each tank will have a dimension of 30 by 90 meters to store the cube moles. So this is how you generally do your analysis or the calculation of the size of the curing tank and the number of beams or cubes required in the project. So to summarize this module, we have done how to calculate the requirements of number of cubes and beams in the project, what should be the required size of the curing tank which one has to make in order to make sure that each and every cube or beam which is being cast in the project will be cured using the resources or the arrangements made. The importance of planning in estimating the size of the curing tank, because depending upon the average quantity or the daily quantity planned, your number of cubes or beams can be estimated. If the planned quantity is high, then probably you end up by investing more on the inventories in terms of number of cubes and beams and also the size of the curing tank. So it is very important to make sure that your estimation will be around the requirement, and it should be as close to the accuracy as possible, so that the planning or the estimation done for number of cubes or beams in the project or the size of the curing tank won't be much. And what should be the right height of the curing tank is also being discussed in this module, because normally we keep 3 cubes in height, so 3 layers of cubes, each cube having a 150 millimeter height, so 3 cubes will be 450 millimeters, and with a clearance of 250 to 300, probably you can have a height of a curing tank not more than 0.75 meters at any point of time, in order to make sure that your cubes are easily accessible and anybody can operate, take out and put the cubes in for curing in the curing tank.